Hello guys, a very good evening to all of you. Today in this particular video we are going to talk about electrolysis and the products of electrolysis. So I hope that you have the fundamental idea of electrochemistry. Okay, so even if you don't have that much of idea, so don't worry, I will make you understand. We will understand this very easily, right? So our main focus is to understand the products of electrolysis. So first of all, what is electrolysis? Okay, so electrolysis basically the flowing of electricity to a liquid, as a result of which the chemical changes takes place inside the liquid. Okay, now we know that not all liquids are electrolytes, right? That not all liquids conduct electricity. Now we know the electrolytes are, okay, what are the electrolytes? So electrolytes are basically the liquids which allow the electricity to pass through it, right? So not all liquids are electrolytes. So there are two kind of liquids we generally deal with. One is ionic molten state, like if you melt the NaCl, like solid NaCl, okay, so you get a liquid form. Now this is called a molten NaCl, okay, and if you add the water to form a NaCl solution, that also conduct electricity. So generally the liquid we generally talk about, one is a molten state, the molten liquid, and is the aqueous form of that solute, right? So in either case we generally apply the electricity and we see that how the chemical changes takes place at their respective electrodes. Okay, now we'll discuss briefly. Okay, so say for example I have a table salt like NaCl. So this is table salt NaCl we use daily. Okay, now I apply the heat to get the molten state. Around 801 degree centigrade we have a molten NaCl. This is your molten NaCl. So I have a container like this. I put, this is your molten NaCl, this is your molten NaCl. I have the molten NaCl. Okay, so I put two metallic electrodes. Okay, I will put two metallic electrode. I will dip the two metallic electrode in the molten NaCl. Okay, now is it sufficient for the electrolysis? No, we have to connect this to external power supply, because we need a power cell, okay, to external supply, electricity supply to get the use of these two electrodes. Okay, now this is a cell. Suppose I attach the cell and I connect this cell to the two electrodes, right? Now what will happen? Okay, now we know the property of metal. Now at the surface of the metals there are many electrons. Okay, they always get a chance, try to get a chance to lose electron, because we know the metals are electropositive. So all the metal have the tendency to lose electrons, right? So now due to the property of the metal, okay, so the metal is try to lose electron and one metal is going to get the electron. So now we have to decide that which metal lose electron, that means oxidize. We know the oxidation reduction in terms of losing electrons and gaining electrons. Now if I am going to lose electron, that I am going to oxidize, and if I am going to receive that electron, that means I am going to reduce. Okay, now the removal of electron, the donation of electron term as the oxidation, and the gaining of electron is called reduction. Now it depends on the potential of that electrode. Okay, now if that is the oxidation potential and the reduction potential, if a metal have the more reduction potential, that means it is going to accept that electron. Okay, and any metal have the more oxidation potential, that means it is going to donate the electron. Now as a result of which one metal gives the electron and another metal gives the accept the electron. Now at a particular time, if you consider, suppose this electrode donate electron and this electrode receive electron, at a particular time this will lose electron more, because the electron density around the metal will decrease and the electron density of this metal will increase, because it's catching the electrons and is donating the electron. So this electrode is now positively charged because it is donating the electrons, the losing of electron to this side, right? And at that point of time we can say this electrode is negative. Now we name this positive electrode is called anode, and this negative electrode we call as the cathode. right? So that we can say that the positive electrode, that anode, the oxidation takes place because it is losing the electron, and this cathode, the reduction takes, and around the cathode and in the cathode there is a reduction takes place because it is catching the electrons. That's why I can say that we say generally there is an oxidation takes place. There is an oxidation takes place at the anode, and there is a reduction takes place at the cathode. Now this is the basic general setup. Okay, now talk about the electrolysis. Now, so initially we have the initial molten state as Na plus and Cl minus. Okay, now these have the separate there is in a separate motion, like in haphazard motion, or they are in a very random motion, or anything like that. But if you see, the moment you put the two electrode and you apply the power supply, the electricity you apply, now this you have Na plus and Cl minus like this. Now we know the opposite charge attract. Now one electrode is positively charged and one electrode negatively charged. We have in the solution Na plus and Cl minus. Now this positive electrode try to attract the negative ion. That's why the chlorine minus, the Cl minus will try to go to the anode, and the positive charged cation, that is, so we call it a cation. Okay, the Na plus will try to move toward the cathode. So we can say we generally say this say this like this, that is, your anion goes to anode and cation goes to cathode. Okay, so this changes that how the ions are separate and this goes to their respective electrodes. This process is called the electrolysis. Okay, so at the cathode, if I talk about the cathode, at the cathode, what is the chemical reaction takes place? At the cathode, you have Na plus. This metal accepting electron from this metal, so that this electrode have a large number of electrons. This sodium atom, once this sodium atom reach the metal, it has the electron. So now this sodium ion get the electron and become in the metallic form. That will transform to the metallic form by accepting an electron. So the charge neutralized to get the metal. Now the sodium, that atom, the metallic atom, is now it is deposited at this, whatever the material, the metal is. So whatever the metal is, now the sodium metal is now going to discharge at this electrode. And similarly at anode what happened? You have chlorine ion. Now the chlorine ion, now this metal is try to donate electron because it is oxidizing, the electrode is oxidizing. So we get by donating the electron, now it become Cl. Now to make chlorine gas, we have to make it Cl2. So if you balance this, so 2 Cl minus give rise to Cl2 and 2 electron, right? So as we can see, at cathode we get the sodium, and at anode we get the chlorine gas. So now the chlorine gas will be liberated at this electrode. Now this is called the electrolysis product. This sodium and this chlorine is called the electrolysis product. That the electrolysis product at the cathode is sodium metal, and the electrolysis product at the anode is nothing but the chlorine gas. Okay, so this is what the electrolysis and the product of the electrolysis we discussed. Okay, now the problem is, suppose we have the aqueous form of NaCl. Okay, so let's take an example of aqueous NaCl. Aqueous NaCl means we have, this is water plus NaCl, means we are going to add the NaCl in a water medium to form a aqueous solution of NaCl. Okay, now if I going to give the same setup to this system, now we have now I said that the cation moves toward the cathode and the anion moves toward the anode. So what is the product of cathode? What is the product at the cathode? So around the cathode you have the ion Na plus, and at anode we have the ion Cl minus. Now as it is the NaCl dissolved in water, now the water is also around this and around, because the water is uniformly distributed throughout the system. So water is present all over the system. Okay, so the water present over here and the water present over here also. Now at the cathode there is also water, and again at the anode there is also water. Now you have to choose the option that which one is going to reduce and which one is going to oxidize, because at the cathode the species is going to reduce, and the anode the species is going to be oxidized, right? Now in that case we cannot say that which one of this is going to be reduced and which one of this is going to be oxidized. So in order to get this, we have to have the general idea, that is a electrochemical series. Okay, we have to have the idea of electrochemical series, so that we can say that which one is going to be oxidized and which one is going to be reduced. Okay. Now if I talk about the general electrochemical series, so in a electrochemical series there is a increasing order of reduction potential. Okay, we know that. Okay, so there is a increasing order. So if you go to the from the top to bottom, there is a increasing in the reduction potential. Okay, so this is a positive reduction potential, is a negative reduction potential. So this is the reduction potential is going to be increased, right? So that means what? The species remain over at the bottom have the most reduction potential, and the species over here has the less reduction potential. And we know that any species have the more reduction potential is going to be reduced first. Okay, so as you can see over here, the sodium and the water, because the reduction potential is going to be increased from top to bottom. So if we see the reduction potential of sodium ion and the water, the reduction potential of water is high. Okay, now between this sodium atom and the water, the sodium ion is not going to be reduced and not going to be discharged in the cathode. Instead, it is water which take part in the reaction. So how it is? I have written down this. The water is reduced to form hydrogen gas. Always remember, the water can oxidized as well as the water can be reduced. So remember this, the water on reduction form hydrogen gas and water on oxidation form oxygen gas. Okay, so as you can see, at the cathode the water is going to take part, that water is going to reduce to form H2 gas. Okay, now at the anode you have the chlorine and we have the water. So if you the FCl, there is the chlorine is over here. So as you can see, now for a species to oxidize, that means it should have the more oxidation potential or should have less reduction potential. So if we compare the chlorine and water, because see, this is the oxidation potential of water, this is the oxidation scale of water, and this is a reduction scale of water. So if as you can see, if you compare this water and chlorine, so which has more reduction potential? The chlorine has more reduction potential. That means it has low oxidation potential. It has less water has less reduction potential as compared to chlorine. That means it has more oxidation potential. Now the water is going to be oxidized at the anode. So here also the chlorine is not going to take part in the reaction. Instead it is water which is on oxidation from the oxygen gas. Now as you can see, at cathode you have the hydrogen gas as a product, at the anode you have oxygen gas as a product. Now if I ask a question that you have aqueous solution of NaCl and what is the product of electrolysis, then we can say that at cathode hydrogen, at an anode the product is oxygen. So this is how we are going to calculate, or we can deal with the products of electrolysis. This is what the product of electrolysis, and this is why we use the electrochemical series. Okay, now let's talk about more example. Things will get more clear. Suppose I have copper sulfate CuSO4 aqueous solution in platinum electrode. So the electrode has the potential or what is the product, it depends also on the electrode. So electrode are generally two type of electrode. One is the inert electrode, inert, that means it's not going to react, and this is a reactive electrode. Okay, we'll see again the in case of reactive electrode what is happening. Okay, so in case of copper sulfate, let's add the cathode, let's do the reaction at cathode and at anode. Now I said that around the cathode you have the cation, and this is cation is nothing but the copper 2 plus, the Cu2 plus, and the anion is SO4 2 mains. Okay, and as it is aqueous, that water is uniformly distributed throughout the system, so water is also present around the cathode, and again water is also present around the anode, right? Now at the around the cathode there is a reaction takes place. Now we have to see that which has the more reduction potential. The species which has more reduction potential is going to reduced, and around the anode which has less reduction potential, that means with a high oxidation potential, is going to be oxidized. Now let's compare of copper 2 plus and water. As you can see, this is your reduction scale of water, and this is your copper 2 plus at the below of water. Now you can see your copper has more reduction potential. Okay, so the water is not going to be take part in the reaction, so it is copper 2 plus. By gaining 2 electron we will get the copper. Now in the platinum electrode the copper is going to be discharged. Now what is the product at the cathode? It is copper, right? Again at the anode, in anode you have the ion SO4 minus and of water. Okay, because water is present all over the system. So compare the oxidation scale of water, this is, and the SO4 minus ion over here. So as you can see from top to bottom, your SO4 ion have the more reduction potential, that means it has less oxidation potential. So the water has the less reduction potential, that means more oxidation potential. So the SO4 again here also is not going to take part in the reaction. Instead it is water, and water on oxidation we get O2 gas, the oxygen gas. So what is the product at the cathode? It's copper, and what is the product at anode? It is oxygen. Okay, so this is the way of calculating the get the product of the electrolysis. Okay, so what is the role of reactive electrode? Say for example, I take same copper sulfate, but it is in, so that aqueous copper sulfate in copper electrode. Now you have the copper sulfate, and the electrode is also copper metal, also copper. Okay, now this copper is reactive. It is not like the platinum. Platinum is inert, that is not going to take part in the reaction. This is inert. Okay, but the copper electrode is now going to be now going to be take part in the reaction. So let me see it is filming or not. Yes. So this copper sulfate, so at cathode what is the ion? It is copper 2 plus. Again there is a water. At anode you have sulfate ion, and also you have water. Now as the copper is reactive, now both electrodes are now copper. Okay, now here also you have the copper 2 plus, and you have the electrode is a copper. Okay, now this is okay. So this here also copper, and here also copper. The copper is present in both sides. Okay, so now you can see the copper 2 plus ion is going to be reduced, because it gained, you have to form the copper by accepting the 2 electron. So as you can see, the copper and water, if you compare the copper and water, the reduction potential of this one, then the copper has the more reduction potential, so that copper plus 2 is going to reduce by accepting 2 electron to form the copper. Now the copper, the length or size whatever is going to be increased in this side. Okay, and the anode you can see. So sorry guys, the video has stopped in between, so don't worry, I will discuss from that point. Okay, now I was discussing the copper sulfate, aqueous copper sulfate using the reactive electrode as copper. Okay, now what is the reaction at cathode and what is the reaction at anode? Now the cation are generally around the cathode. What is the cation? The copper 2 plus. Again the copper, as the copper electrode is present as it is, now copper is also is in cathode, because both the electrodes are now copper, because we are using copper. So as the copper is reactive, so unlike the platinum electrode is non-reactive. This is the inert electrode. So in which part it will be, like in anode or cathode, it is not going to be take part in the reaction, but it is copper is reactive. So as both the cathode and anode are copper, so metallic copper, so here also copper, so here the metallic copper is present, because the both cathode and anode are made up of copper, right? So and there is water in both the case. Now what is the anion at anode? It is sulfate ion, SO4 2-, right? So these are the ions and the species that is present at cathode and anode. Now we have to decide that which is going to be reduced at cathode and which is going to be oxidized at anode. Okay, now at the cathode, if you see that copper 2 plus has to be reduced to get the copper. Okay, you can see this, as you can examine from this one also, verify this from copper 2 plus and this one. Okay, if you compare this, the reduction scale of water and the copper 2 plus, that the reduction, because it is going to be decrease, sorry, it is going to be increased from top to bottom, so the copper 2 plus has a more reduction potential, so it is going to be reduced to copper by gaining the 2 electrons, by accepting the 2 electrons. Okay, this is at the cathode. Now what is the anode? As the anode, you have to, this water is now this one, because it is going to be oxidized, right? Now if you compare this water, this copper and this SO4, this copper, this water and this SO4, which has more reduction potential? This one. This means it is a less, this is more reduction potential, that means less oxidation potential. This copper 2 plus, the other copper generally, this have less reduction potential, because it is going to increase from top to bottom. So in between these three, so this copper has the less reduction potential, that means more oxidation potential. Okay, so this copper 2 plus, because the copper has a more oxidation potential, so is now going to be oxidized to copper 2 plus 2 electron. Now what is the product at cathode? The product as a cathode is copper, metallic copper, and what is the product at anode? It is the copper 2 plus ion. Okay, so this is how we generally talk about the product of electrolysis, right? So one thing I just said earlier is wrong. Is basically, it is I have said this is your negative and this is positive, because it is going to increase the reduction potential. Okay, so this is the negative part, and this is the hydrogen has the 0 volt. So this is a reference for the calculation. What is the value? So there are many values are there. I am not writing this writing this values. This is not necessary. Okay, so what is to remember is the sequence, that the order or the sequence of the reduction potential. Okay, and mostly the sodium, the two hydrogen scale, like the reduction and oxidation, and the copper, okay, silver and sulfate. Okay, these are some important ion. Okay, we need to be very sure about the sequence of the reduction potential. So from top to bottom there is an increase in reduction potential. Okay, and from top to bottom there is a decrease in oxidation potential, because oxidation potential is exactly negative to the opposite one. This oxidation potential is exactly negative to the reduction potential, and vice versa. Okay, so this is what our discussion about electrolysis and the products of electrolysis.